Hi, I'm Brendan Radeball, and I'll be your host for the Orlando Regional Workshop Series. Thank you to the Orange County government for putting together this series. I'm here with Dan Swando. Dan, what are we going to be talking about today?
Well, we're going to try to CAD up a robot in less than an hour.
Less than an hour. That's a challenge that's going to be exciting.
Yeah, we'll see how it works.
Okay, if you want to tell, what is CAD?
So first of all, CAD is computer-aided design. It's how you design stuff on the computer before actually making it in real life.
And how would we use that in robotics?
Well, for any engineering project, you want to plan stuff out before you start cutting material. You want to figure out what components you have available, and for engineering, CAD and design is how we communicate the design to the team.
And which CAD softwares are available to FIRST students, and which one are we going to be using today?
Well, there's a couple out there. Autodesk has both Fusion and Inventor. There's PTC has a software, and of course SolidWorks is available for a student package.
Okay. Now, which one are we using?
And so I'll be using Inventor, but a lot of these techniques are also very useful in SolidWorks and the other CAD programs.
Okay. If we want to get started, can you tell me a little bit what we're looking at in Inventor right now?
All right. So this is the interface, and what I'm going to do right now is I'm going to first open up the field. You can download the field. I downloaded the 2020 field from Autodesk.com. Any team can do that. It comes in. If it doesn't come in the language that your computer speaks, there are also what are known as neutral formats, and these neutral formats can be used by any CAD program, and that's how engineers actually get designs from one CAD software to another.
Okay.
So this right here is the FIRST Robotics field, and one thing that I'd like to note off the bat is when I pulled this in, I pulled it in as a virtual part. You can pull it in both SolidWorks and Inventor as a virtual part. And what that means is it doesn't load the entire field, all 5,000 pieces in the assembly, and that's the first thing that's going to really make this more enjoyable, because otherwise the computer would lag it would get very slow.
So it's every little piece is doing it as one big puzzle.
Yes, exactly. It's not loading the material properties or the weights or the center of gravity of every little piece.
Okay.
And so that minimizes the amount of calculations that the program has to do. What I like about the field is you can divide the field very easily using your origin planes. And that's actually the first thing that is my first advice is you should follow these planes in everything you CAD. You can divide the field into left and right sides, front and back, and the XZ plane is actually the floor surface. So this is a very well assembled assembly. Something to note for everybody that's in school is you'll notice in CAD land, CAD follows math or in terms of orientation. So your right-hand rule, you have your x-axis goes left and right, your y-axis goes up, and your z-axis comes out at you out through the screen. This differs from other things such as 3D printers and CNC machines, because in the manufacturing world, Z is up and Y is out,
towards you.
Towards you. So So that's the first thing that a lot of people will end up getting mixed up on. I prefer to keep my XZ plane as ground level, just as you see here.
And do you usually like to keep it on the isometric view, which is the corner view?
It's just the prettiest view. But sometimes you can see more on any view, but especially when you're trying to measure dimensions very nicely. But yeah, isometric sometimes gives you the clearest view. So for example, I'm going to go ahead and take my measuring stick and I'm going to measure the distance to the goal. I'm going to pick a point here, and so that's about 98 inches, 2.5 meters. Yeah, and you can actually see that right here is 98 inches. So that's a number that I'm going to use when I'm doing my next thing, which is we've got the field. I know that I want to shoot balls into the goal. So let's see what that looks like, and you can do that using a model. And so what I'm going to do is I'm going to create an arc of how I want the ball to fly through the air, and you can definitely use trigonometry to figure this out as well. And what I'm going to do is I'm going to throw some dimensions on it. So I've got 98 inches to the goal, and I'm going to start it from wherever my robot is. And so I'm going to say that it's going to be about 54 inches, and that's a bit ridiculous of a curve. So what I'm going to do is I'm going to try to constrain my dimensions a bit more.
So when you say you're constraining your dimensions, it means you're just trying to keep it on the 0 axis.
Yeah, so one thing that's really important when you're doing CAD is you want to, this is not good when you can just drag things. You want to be able to add as many constraints as you can to make it fully defined, to fully define what you're working on. Otherwise, you can be working on something and you'll just drag something, and then all of your measurements, your very nicely calibrated measurements, are going to be off. But we're just going to create a path and a couple of pieces along that path, and yeah, what that's going to be is where my ball's going to fly out. I'm going to create a rotation axis here, and I'll show you what I'm doing with that. Is you can do this in SolidWorks. It's really easy to make a path and put points on in an assembly mode. In Inventor, you have to add one more step, which is do that in a part and then bring it into an assembly. And so this is where our ball is going to be. And so I'm going to create a mini ball. And I'm going to revolve this ball.
So you're creating a solid object right now.
Yeah. try that one more time. All right, so that didn't quite work out the way that I wanted to, but fortunately I've got a backup, which is, I already did this before, and I created my path, and I'm gonna hide that. And so I've got my balls flying through the air. And so now I can go into my field, and I can actually pull that model in. Let's try that again. So I'm pulling my model in. So now I can see how the ball is going to fly through the air on the field. And this is going to be useful because it's going to help us figure out where we're going to put our ball shooting mechanism. So I'm not going to design that yet because we're going to have to prototype that out. Our team's going to have to prototype that out. So what we're going to do is we're going to create a base model of the robot, and we're going to figure out how the robot's going to go together. So a couple of pieces of advice that we're going to do is we're going to put, we're going to group our parts together by what subassembly they go with, whether it's the drivetrain or the midsection of the robot, or whether we're going to buy it. We're going to we're going to try to mate everything together so that we've got a good idea of where this is on the field. So that's what I'm doing right now. I'm going to take that that part that we made, that basically is where it's still in a sketch at this point, and I'm going to mate it to the field. I'm going to say that it's probably going to be about 260 inches away from the center of the field, and I want to mate everything to the origin planes that we mentioned before, because what happens is if you mate it to the field itself and then the field goes away, it's going to give you a bunch of errors. So we don't want that. So we're going to mate it to the origin as much as possible. And when you say mate it to the field, that means that you're taking one sketch and putting it on the XYZ plane of another sketch. Well, I'm taking the assembly and I'm building relationships. Yes. Building relationships is important both on a robotics team and also in CAD. Continuing to add more dimensions. So it looks like this is where I want to make my robot, right here. My robot's going to be about 60 inches high and we'll say 30 inches wide. And we're going to be about 60 inches away from the goal. So to make things simple, let's go ahead and take the FIRST Robotics kit chassis. The kit chassis is going to be a great first start for prototyping. We can build it really quickly, and we'll be able to build it in the first week of the season, and we'll be able to and roll around with it and do a bunch of prototyping of our ball mechanism on it. So I was able to pull this frame from Andy Mark, Animark's website, I was able to get the kit chassis. So what I'm going to do is I'm going to take this chassis and I'm going to build off of it. So I know the overall size of the robot. I can also, by the way, I can get the kit chassis either just by itself or already built up with the wheels and motors too. So all that hard work has already been done for me, so I've already saved myself a bunch of time.
So all those can be downloaded off of Animark's website.
Yeah, and the nice thing about design is you can, because these are all commercial off-the-shelf pieces, you can actually design this before the season even starts and tweak your chassis, your design, based on whatever the game is. So this version has an open spot, so we can put together a ball mechanism. And so everything is being mated to my origin. And like I said, that's going to be extremely important to figure out. I want my ground to be underneath all the wheels. So I want my ground level to be the floor. And you can see the CAD model that I imported doesn't have a perfect mirror image, so I'm going to have to adjust some of these mates. What I did is I just mated my X plane to my X plane, my Y plane to my Y plane. So I need to create offset, looks like maybe 2 inches on one dimension and 0.3 inches on the other, and that gets me my nice mirrored XY planes.
And this chassis is the drop-centered wheel chassis, correct?
Yes, it's got 6 wheels and 4 motors, and this should be a very versatile chassis that should match up against most other robots. So now that I've mated this chassis together, what I'm going to do is I'm going to give you a different perspective. If instead of using the kit chassis, you could also do this with a nanotube design. And the nanotube is an Animark product where you can have your drivetrain completely configured on the left or right side. And so what I'm going to do is I'm going to hide my kit frame here and just show you how you can do the same thing utilizing drivetrain components. So I'm going to go to my Nano, I'm going to grab my assembly, I'm going to place it in my assembly, and of course I'm going to have to go in and select my planes and mate them up with my origin again. So I've got my center line, the drop down third wheel is going to be my center line. I'm going to offset my plane by a couple of inches, let's say 4 inches, because I'm probably going to use 8-inch wheels, or maybe I'll change that depending on what wheel configuration I make. And then I have to offset my XY plane, and that's going to define how wide my robot's going to be. So I'm going to say it's going to be about a 30-inch wide robot, so I'm going to offset it by, let's say, 14. So now I brought it a bit down, so because what you have to realize is it's selecting the center point, so your overall width is going to be a bit wider than your dimension. So that's why I did that. So now I added another Nano rail. I'm going to constrain them together using those planes, and since I want them to be in the same horizontal plane, my XZ plane, I'm just going to mate them directly together, and then my width, I'm going to offset it by 28 inches, and now I've got a 30-inch wide robot. So you can see with the planes that everything is mirrored, and this is going to be really handy to set up the rest of your robot because you can reference everything to those 3 planes.
So that's basically going to be your base of the robot.
Yep. And then I can throw some motors on it if I want. Yes, I know. It's important to define your project, otherwise you end up with a couple of errors. That's one thing that you don't have to worry about in SolidWorks. But I'm going to mate my motor to my Nano rail. And in this case, I actually will select the geometry because I'm pretty sure that my design is going to stay pretty consistent. So I go ahead and mate that, and I can go in, add another motor if I want, or you can download all these components from AndyMark, but what I want is a wheel. So I'm going to take 2 wheels, I'm going to constrain those to my shafts.
Now, when you download these components off the AndyMark website, andymark.com, it's also going to give you the weights of the items as well, right?
Yeah, so it's really handy just to download these items if you're planning on using them, because it's got a lot of the properties involved. You can pull weights off of it, and you can figure out where your center of gravity of your robot's going to be. And figure out how heavy it's going to be, and that's going to be critical. It's critical to figure that out during the design time, instead of waiting till you built a robot and found out that you're 50 pounds over and you're going to have to remove components.
So less cheese holes.
Yes. At best, cheese holes. At worst, you're going to lose some functionality that you wish you had. So. Now I can mirror those wheels, and I can, by adding this plus sign, that means I'm going to reuse the components. It's not going to create a mirror image. I'm just going to mirror the relationships between objects. I can do the same thing with the motor, mirroring the component around the X or the YZ plane, and so now I've got my mocked up chassis, and I can add some structure in between if I want, but I'm not really sure how that's going to work out right now. This is still day 1 of build. We got a couple weeks to figure out all these little tiny details, but I've got a chassis.
So this helps you get the general dimension of how big you want your robot to be in the constraints of the game.
Yes, exactly, and that way you can start mocking up, okay, what's it going to look like to build stuff on top of it, and this is how you communicate to the other parts of your design team on what the base is going to look like.
So don't wait till the very end to figure out where your battery is going to go.
Exactly. So let's we're going to get to that part. But first, let's do it with the KitBot chassis, because it's a bit easier to visualize once you have the entire frame together, right? So let's add some more components. Sure, let's do some electronics. We know that we want to have our electronics. We know what pieces are involved with our electronics. We have our driver station, the circuit board, and all this stuff can be laid out by your electrical or controls team at the same time, and you can have somebody else working on it, and just drop it in. In this case, I actually have it using the same origin planes as I did before. It's got a left and a right side. It looks like it's slightly off from where our center of our robot is, so I can just take those planes, and I can add a dimension to that to offset that. And let's see, I'll put it at 4 inches offset. And what this does, you can now see, it's perfectly mounted to the holes in the rail. So I can feel pretty good that our electronics are going to fit on that. Yes, but we are missing battery, but we'll figure that out pretty soon. But first, what I want to do is I really want to show what happens now that we've got our chassis, and it's got the electronics on it. We've got a pretty good idea of what it's going to look like. So it would be really handy if we can see what this robot looks like on the field. So what I'm going to do is I'm going to create a next level assembly. And what this allows me to do is I can put in my chassis assembly, and I can put in other assemblies, such as my upper half of the robot and everything else, without affecting this, because you don't want everybody working on one assembly. That's going to take a very long time. So it's going to be better if I've got this next level assembly, and of course I have to mate it up to the origin again, and now I can add in my previous trajectory, and I can mate that to all the planes. I can constrain that. It looks like it's a bit backwards to where I want it, but
now when you say the different assemblies to mate them together, that's just because you would want to have your primary mechanism, your secondary, and your drivetrain separate, just in case you wanted to build in the same in those files separately.
Well, you can have multiple people working on different pieces of the robot in CAD. So you can have one person working on the trajectory at the same time that somebody else is working on the chassis. And so this allows you to put it all together and very, very easy to see. And so now I can go to my field, and I have the one piece, but I can take the trajectory and I can replace this. It's similar in both SolidWorks and Inventor. In Inventor, you go to the component, replace. In SolidWorks, you just replace it with a right click, and you can replace it with that assembly. But I first actually need to save this assembly. That's right. So I need to save that as my robot layout.
Save often, save continually.
Absolutely, because that's going to make things that's going to slow things down a lot if you forget to save and your computer crashes or something else happens. So now I can go to component and I can replace my trajectory with my robot layout. All right, tells me everything's going to be the same. All right, so we've got it, and it's not quite the way I want it because it looks like one of my mates is a bit backwards from where I wanted it. So I just changed that around, and I offset it there, and now I've got my robot shooting into the goal. And it's all that in only about 15 or 20 minutes.
And this also would help with figuring out your actual strategy for the game as well, trying to see, do you want to have a robot that will do layups to the targets, or where will the robot be in general for the game?
Yeah, you just put it, you can manipulate your robot around the field. You can add multiple instances of your robot around the field. So now we can see where our robot needs to be. Yes. Inventor has levels of detail to define their assemblies. In SolidWorks, they use configurations, but all that means is it's just different configurations of your robot, and Inventor likes to make you save it every time. So now I'm going to save my field. And now we can start working on the upper part of our robot.
Okay.
So what we're going to do is we're going to take some pieces of metal. You're going to have some metal in your shop. You might use angle aluminum, you might use seat channel, or you might use some other extrusion type to put your robot together. And so you can actually take these pieces and put them together in multiple different configurations. So once this is done saving, I'll be able to show that. Setting up your planes is very important. All right, so now I've got my aluminum channel.
Now, some of these base items, did you create them yourself, or was it something that you had downloaded?
Some things I have downloaded. This base channel is something that I made beforehand, and I've also got an angle. What I do here is it's actually really simple. It's just a couple of pieces long. It's a simple extrusion. I've got a 2x2 extrusion that I extruded into a flange, and I've got my thickness defined in my sheet metal, and that's all I did with this. And then I've got my holes, and so I'm in this case I've got a hole pattern, and I'm going to create a rectangular pattern, and this is my base material, and just for visualization purposes, I can have a hole every inch and show it. So what I can do is I can change the number of instances to make it longer or shorter, and I can use this piece for a lot of different pieces of my robot.
So it's just an all-around piece for you to be able to use a structure.
Yeah. So similarly to my C channel, I've got my pattern. I've got my piece. Now I'm going to put it into my my robot part, but I want to first figure out. All right, so I've got about 5.25 inches to the top of my chassis. So I'm going to create a new assembly to put in my components, so that I don't mess up my chassis assembly. I'm going to place the piece that I just made, that angle channel, And I'm going to have to mate that to everything. But first I'm going to change this length to, let's say, about 50 inches. And so now I've got a 50-inch long piece, and I can save that off onto a different component. I can make multiple copies of that of different lengths. But right now I'm just going to take that one piece that I have, I'm going to mate it to my origin at that 5-inch offset. Then I'm going to mate the other planes. I'm going to mate my YZ plane like so. I'm going to give that an offset of 14 inches, so it should be right above the edge of my robot chassis. And then I can mate the front side of my channel, and that's probably good where it is. So now I've got one piece. I can mirror that piece, and I want to use the same component and mirror it around the YZ plane. And add that, and then I can pattern both of those items and pattern it along my Z axis. So that's going to be front back, and make that 12 inches apart. So now you can see I've got 4 vertical elements to put all of my stuff into. So now I go to my robot layout. First I have to save that assembly as my, let's call it my robot midsection.
So this would be your primary assembly other than your drivetrain.
Yep, so now I can take that midsection, go to my robot layout, and go ahead and place that robot midsection. And then I can mate that to the rest of my robot. And this is much faster than trying to mate, go and select each individual face and try to select faces. So you can see I was a bit off. I was about 1.5 inches off. So what I'm going to do is go back into my assembly, and because I mated everything to the plane, I can just change that to 15.5 inches. And that'll change my mirror, and I need to, it didn't change, so I need to update it. So, oh, but it only did one side. So I got to go back and into my second channel, and I have to do the same change with that mate. See, it recreated the mates because I told it to reuse the same components. So now I make that 15.5, and I go back and update, and now you can see it's pretty close. Things are kind of crashing, but I've got a general idea of what this robot looks like. So
how
now,
tall it's going to be.
Yeah. So now I can go to this assembly and update it, and you can see how it fits into the field. So now I'm going to add a turret, because I think I'm going to want a turret to put my robot, to put my ball mechanism on. and I know that my team has this turret from a previous year, so I go ahead and reuse this turret.
Reuse the asset that's been created?
Yeah. So then I know my team had it modeled. We pulled it off of a website, and so now I take that turret and I just do the same thing. I mate it to the rest of my robot, and I put it where I want it. In this case, I'm going to be a bit lazy, and I'm going to take that turret and just made it directly to my axis, and it moved out of the way, so I just need to create a offset for my z-axis, or my y distance, and we'll say about 55 inches. And now I've got a turret to put on my robot. And we're just going to have to create a platform, or figure out a way of mounting that turret to the robot. But overall, you can see the benefit of having CAD and playing with your robot before you even cut your first pieces.
So with this basic assembly, we now know what our drivetrain is going to look like, how tall our robot's going to be, and also what our primary mechanism is going to start to look like. And then we can start adding into how do we get the playing piece from the ground to the primary mechanism,
Yeah.
and be able to build off of that.
Exactly. So I had to reload that. So there we go. So yeah, and let's make sure that we do add that battery, because that battery is going to add a bunch of weight to our system. And in fact, I think there's some more components that I got from Andy Mark. I can get the battery mount assembly. We don't need churro.
And like we said before, you can use the CAD software to emulate the weight of the robot, so you can create a completed robot in CAD and know the general weight of it.
Exactly.
So less cheese holes. And you always want to work on where the battery is going to go before you finish the robot.
Yeah. One other thing to remember is make sure that you save it to the same spot, because I moved all my files, and now my relationships aren't lining up. But I want to have my battery approximately in the center of my robot. Don't know where it went, but we'll find it soon enough. Oh, there it is. I'm going to say that that's going to be 5 inches up, and looks like we're going to have to move one of these components, but right now we'll just leave that, and I'm going to mate that battery.
So we can also use where the battery is going to be placed to know where the center of gravity is going to be on the robot.
Yeah, so in SolidWorks they have a measure parameter that you can look into that in Inventor. It's under iProperties, under Physical. And we can update it. Oh, it really wants me to save this, doesn't it?
That's nice. It used to never ask you to save.
All right, go back to iProperties. calculating.
It's taking all those base measurements and figuring out where your center of gravity is.
Yeah, and so I already know that my robot already, including the battery, is going to be 72 pounds. And this tells you where your center of gravity is in X, Y, and Z. And this is why it's critical to set up your origin correctly, because now I know where everything is in relation to my robot just by knowing where it is in X, Y, Z space. I know that in my Y direction, I'm a bit top heavy. My center of mass is going to be about 35 inches above. And now that it's also including the balls, so you got to remember to factor that out as well. In fact, let's do that, because that's why.
Yeah, it's calling those a giant mass.
Yeah, and it probably thinks that it's solid steel too, which is probably
It's not a poof ball.
Yeah. No, that didn't significantly change it. So, but I do have that mass up there, and so that is actually why. And so figuring this out is a good way of checking. Having a turret up there might give us a really high center of gravity. So maybe we want to redesign this so that the turret's further down. In the X direction, we seem to be pretty balanced left to right. And in Z, we're in the positive X-axis, or positive Z-axis, about 8 inches. So it must not be calculating that battery.
Now, where can we find some resources if somebody is first getting into CADing?
So you can always go to YouTube. YouTube's a great resource. If you go to one of the FIRST forums, like Chief Delphi, they've got a lot of information on CADing specifically for robotics, and there's a lot of teams that have already made these components. So a lot of the work has already been done for you. You just need to go and get it. See, now it's saying our center of gravity is going to be slightly behind the center of the robot. So that seems a bit more correct with adding the battery weight in. But because this heavy weight of the turret is right around the center of our Y, Z, and XY planes, it's really pulling the center of gravity back towards the front of the robot. So we've got a pretty well-balanced robot here.
So not going to tip over yet, but we still have a lot of mechanisms to add into it.
Yes. So, but now we've got a good start for our robot. Is there anything else that you think that we need to add to our robot?
Probably a shooter, but we can go in. That's a whole nother lesson.
Well, we got to prototype that, but I think one more thing that we're going to need is we're going to need some bumpers.
Oh yeah, bumpers are always good.
So we don't need to design our bumpers right now. We can wait until the season is pretty much more moved along before we make our bumpers. But we do want to show, for the purpose of pulling it onto the field, what that is going to look like with bumpers, so we know how much we need to interact with, or how much we can interact with different field elements. So we know that our robot is about 30 inches wide and let's say 30 inches long. And I also know that bumpers tend not to be totally square shaped. They usually have a radius, but actually I'm going to do that in my other plane. So I created a path, my robot perimeter, And now I'm going to take a very simple bumper. I'm going to make sure that my bumper is 3 inches off the ground and it's 4 inches high, and my bumper will be about 2 inches deep, and they're going to be filled with 2-inch pool noodles, which will have a radius of 1. And so that's probably going to be about 15 inches away. All right, so I made the cross section of my bumper. So what I can do now is I can do what's known as a sweep, and I can take that cross section and I can select my frame perimeter. That's okay. And I've got my bumpers. And are you a blue bumper fan or a red bumper fan?
Usually red bumpers.
You like red bumpers? Okay. So I'll make them red bumpers. Save that. Now I can take that bumper all right. Now, it looks like bumpers are a bit high, so I can go ahead and change that by 1 inch, and I'll go ahead and open that up. And give ourselves a 20-inch opening. Make it a cut through all. And I'll go back to my sweep and change this to 2 inches. And now I've got a pretty good robot. I can throw that robot back in.
So now we can see the exact size of the robot to the field itself and see what obstacles we might have an issue with.
Exactly, and you can drag that all around. And that's the we're less than an hour into the first season, and I've already got a pretty substantial start to our robot build.
So now we can work on strategy and figure out how we want to play the game, and also figure out how we're going to build the robot off of that strategy.
Exactly. So a couple more pieces of advice for when you're putting your robot together is don't be as concerned with adding every little fastener. That's going to really slow you down. If anything, you can put in just one fastener and do a pattern. That's usually really quick. You can, or you can just, if you're going to go to the next step and create drawings, you can actually just put notes on the drawings to add whatever fasteners you need after the fact. Another thing that you should be doing is, as I said, put things into folders. You're able to, in an assembly, let's say if I actually put my electronics board inside my chassis. So I don't want that, so I can actually promote that.
And that'll keep you more organized.
Yeah, so now my electronics is not in my chassis, it's separate from my chassis. But now I can take my electronics and my bumper, I can add to a new folder, and I can call that electronics. And this is helpful if you already have like 20 or 30 components by separating them into folders, especially if they're named something weird and you forget what they're called. The motors will come in as their Andy Mark part numbers. And so if you don't remember that the 217-3371 is a sim motor, or the 217-8080 is a
Speed controller,
then it's handy to put them in the folders so that keeps you organized.
Okay. Well, Dan, thank you very much for showing us how to build a robot and through CAD. Like you said, all the resources you can find on the different websites. So all of the components, you can usually find a lot of components on andymark.com. AutoCAD and SolidWorks and all those programs have classes on their websites as well if you want to go through it. And also FIRST has a lot of documentation that we can use as well. Thank you again for joining us for this workshop series. And thank you again to the Orange County government for sponsoring our series.
Thank you.
FIRST Robotics Competition is the world's landmark robotics competition for students.
In school, you read about stuff, but in FIRST as a whole, you actually go and do it.
In the beginning of January, the challenge comes out every year. Under strict rules and limited time and resources, you have to design, build, program, and test a robot.
There's no blueprint. We get a few rules and guidelines to follow, and then it's up to those students to find something that works.
There's nothing better than just seeing your robot on the field playing for the first time. They're all there like, is it gonna work? Is it gonna work? And then when it works, it's the best feeling ever.
You have mentors that are actually in the field that can tell you, oh, this is why this works, and this is the science behind it. And you're like, oh, wow, that makes so much sense.
They do a great job, not just about STEM, but about life, how to go through college, how to go through, a tough, physics class.
At face value, FIRST Robotics Competition is a robot competition, but at the end of the day, it's so much more than that.
People ask me like, oh, you build robots? I says, no, we're really running a business and all the things that go along with that.
We deal with a lot of marketing, social media.
I've learned business side of things,
problem solving, working in groups.
I'm learning how to communicate with people, how to reach out to local businesses.
So we kind of have robotics as the starting point, but we branch out to different areas and expand.
So the ultimate goal every year is always to get to the FIRST championship.
The FIRST championship is basically like the Olympic for robots.
There's hundreds of teams from all over the world there, and you get to see some of the best teams that exist.
It's very competitive, but you're friends with the people that you're going against. It's like a sport, but in its own way, it's better than a sport.
Being part of FIRST, it's really changed my life and how I think about myself, how I think about others.
Participating in FIRST actually taught me that I'm capable of doing anything that I set my mind to.
FIRST has really inspired me to give back in my old elementary school. I'm trying to help their robotics program that just started this year. I want those kids to have the opportunity to learn about STEM.
As a participant in the FIRST program in high school, you get access to $80 million worth of scholarships.
There are scholarships for colleges, universities, as well as technical programs.
It also looks really good on the actual application to be on FIRST.
FIRST does a really great job trying to open programs to make sure that you could actually accomplish anything in STEM, no matter where you're from, your background, your language, or anything like that.
I really do consider myself part of the STEM community, and I couldn't be more prouder to say that.
FIRST Robotics Competition is one of 4 engaging FIRST programs that shows students unique challenges and helps them learn new engineering skills and real-world skills that'll help them in the future.
First is the future.
First is accomplishment.
First is passion.
First is inspiring.
First is changing my story.